So in this worksheet, I'm going to talk about net ionic equation. So first of all, there is a concept that I did not tell in class, so I'm going to point it out on here. Is in this worksheet, both the reactants are always aqueous. Both of the reactants are aqueous, so you don't have to check the solubility for the reactants, but you have to check the solubility for the product. Okay. So first of all, let's talk about the spectator ions. What's the definition? This is going to be on the test. Spectator ions are the ions that remain soluble and aqueous in water, meaning before and after the reaction, they always stay soluble. They always stay aqueous. So when we're talking about what exactly will happen on the net ionic equation, meaning what happened during the precipitation, these spectator ions should not be included because these spectator ions are the ones that just stay aqueous before and after. They did not precipitate in the reaction, so we should not include them in the net ionic equation because the net ionic equation is talking about after I cancel all my spectator ions, whatever left over responsible for precipitation. Okay, now these spectator ions, they show up on both sides of the equation with same coefficient, charges, and state. So if you see them, they show up on both sides of the equation with the same coefficient, charges, and state, you should cancel them. Okay. Now we have three different kinds of the equation. We have molecular equation ME, which is just a regular formula equation, And then the TIE, the total ionic equation, is when I start to separate the charges, total ionic equation. And then the net ionic equation will be after I cancel my spectator ions. So after I cancel my spectator ions, this will be left over net ionic equation responsible for the precipitation. Okay? Now, let's say you're done with your net ionic, and this is what I got. Okay, 1Fe3 plus aqueous plus 3Cl minus aqueous to form 1FeCl3 PBT. So let's say this is the one that I come up. How will you know that this equation is correct? You gotta check in 4 different ways. Okay, you gotta check all of them. So number one, whether the equation is balanced by drawing the chart. Okay, to compare the Fe and Cl. Are they okay? Check mark. Number two, check the total charge of the whole thing is to see if it's 0. So remember we did the positive charge is 1 times plus 3 equals plus 3. Negative is 3 times negative 1 would be negative 3. They should add up to 0. And this actually, the 0 charge should be the charge for precipitate. There will be no charge for that. And number 3, you want to do crossover to see if you come up with the product. So I did crossover Fe3 plus Cl1 minus. I crossover, I do get FeCl3, which is my precipitate, which is good, check mark, okay? And then number 4 is going to check up to see if we have met the double displacement condition. Now the double displacement condition is we met if the reactant is aqueous for both of them. So in this case, Fe3 plus is aqueous, Cl minus also aqueous. And then the other condition is whether we form the precipitate, water, or gas. So here I do form precipitate. So check mark. If these all 4 conditions are met, that means your net ionic equation is correct. If anything doesn't match, that means something wrong with your net ionic equation. Okay. Now, whenever we see aqueous compound, because aqueous is soluble, we got to separate the compound into positive aqueous and negative aqueous. And then whenever we say precipitate, because precipitate is insoluble, there will be no separation. We're going to leave the compound as precipitate, meaning no charges. So there will be no charges PPT. Okay, PPT will be just 0 charge and no plus or minus and no separation. Right? So let's do number 1 here. So number 1, we're going to underline the outside, right? The 2 outside, the first and the last with the negative. We write down the charges and we draw the rainbow, right? PP2 plus Cl minus, we draw the rainbow, and then we bring the cloud to here. And then the negative inside too, we also underline them, we draw the rainbow, and we bring them to the second. And then we cross over them back, we got lead-2 chloride, and then potassium nitrate. You can actually do crossover to form the compound, or you can, you see that the crossover, PP2 plus Cl minus, you cross over, you get lead-2 chloride by potassium nitrate, or you can actually simply read it from here, lead-2 chloride, potassium nitrate, but be careful, positive go first, so it would not be nitrate potassium, it would be potassium nitrate. So they would be just like our regular Worksheet equation. Now we're going to start to write the molecular equation, which is the formula equation. So you can basically just cross over the charges back. Okay, and then I'm telling you, in this worksheet, both reactants are always aqueous. So the both reactants are always aqueous for this worksheet. Okay, and then here, the electric chloride, you have to check the solubility from the table, solubility rule. Okay, this is a PPT, so I'm going to put blue color. And then potassium nitrate, which has a solubility rule, will be aqueous. And after you write down all the state, you form all the compound, then you're going to balance them. Will be 1, 2, 1, 2. I'm not going to go through the balancing. So that would be your molecular equation. Now the total ionic equation is when you see the aqueous, you're going to split into positive AQ and the negative AQ. Whenever you see PPT, you leave it like that, no charges, no separation. So here you have to be careful with how many charge and the state. So here I get 1 PB. PB what charge? PB 2 plus. So 1 PB 2 plus AQ, because AQ I separate into charges. And then here I got 2 NO3. 2 NO3 what? 2 NO3 minus charge, and then it's AQ. And then here will be 2K plus AQ, 2Cl minus AQ. So the first line is the reactants. And then I'm going to draw the arrow, go to the product. Now, because this is PPT, we are not going to change anything. Don't separate them, don't give them charge, just copy. PbCl2, PPT, no separation, no charges. And then this is aqueous, so we're going to separate it. Will be 2K plus AQ, and then 2NO3 minus AQ. So this one before the cancellation will be so let me maybe, I think I should, actually, so this one will be like the total ionic equation. Okay, so after that, we're going to cancel out the spectating ion. Spectating ions are the one that you show up on both sides. So which one is going on both sides? 1 pp2 plus AQ does not show up on both sides. Don't touch it. 2 NO3 minus, 2 NO3 minus, they show up on both sides. Exactly. Coefficient, charge, AQ, everything. So we're going to cancel this too. 2K plus AQ, they also show up on both sides, so we cancel them. 2Cl minus AQ does not show up on both sides, leave it. PbCl2, PPT also did not show on both sides, leave it. So after I cancel the spectator ions, then whatever left over will be net ionic. So it will be 1 Pb2 plus AQ, 2Cl minus AQ, and then arrow to 1 PbCl2 PPT. This will be my net ionic. Okay, this will be my net ionic. What happened exactly on the precipitation? Okay, just I'm only interested in the precipitation. Now I'm going to check to see if this equation is correct. So first of all, I'm going to check the charge. I'm going to check the balancing. 1 PB, 2Cl, 2Cl by drawing the table. Check mark OK. And then we're going to check the charges. So positive charge will be 1 times plus 2 equals plus 2. And then negative will be 2 times negative 1 equals negative 2. They should add up to 0, which is a charge for precipitate. Should be no charge, which is good. And then number 3, I'm going to do crossover. So Pb2 plus Cl minus, I cross over. I got PbCl2, which is my precipitate, which is good. And then number 4 will be the reactant. It's just the double displacement condition met. So my reactant is Pb2 plus AQ, okay, and then Cl minus AQ, which is good for reactant. And my product is PPT, which is also good. So if these 4 conditions are met, that means this equation is correct. Now I'm going to do the number 2. Okay, so number 2, we're going to do the same thing. Be2 plus, SO42 minus, draw the rainbow, bring them to the cloud. Iodine minus, CO plus, draw the rainbow, bring them to the cloud. And then the 2 are aqueous, so we don't need to worry about that. I'm telling you, this worksheet, the reactants are aqueous. And then we're going to cross over back. This is beryllium sulfate, copper 1 iodide. Or actually, you can read it from here. Beryllium sulfate, copper 1 iodide. Make sure that you have the positive first. And then you're going to write the molecular equation. Okay, you're going to write the molecular equation, and then you're going to find the state. The 2 states for the reactant in this worksheet are always aqueous. And then we check the solubility rule. BeSO4 is also aqueous. CuI is also aqueous. Now this one, even though you know that there's no reaction take place because of the no PPT form, I still want you to balance them because we're actually going to prove why there's no reaction take place. So you have to still go ahead to balance them. And then after I balance them, I'm going to separate them because of AQ. So 1BE2 plus AQ, because they're all aqueous, then we all have to separate them. 1BE2 plus AQ, 2I minus AQ, because I have 2, and then I minus AQ. 2Cu plus AQ, because I have 2Cu. 1SO4, 2 minus AQ, because 1. And then on the product side will be 1BE2 plus AQ, 1SO4, 2 minus AQ, because I'm here, and then 2Cu plus AQ, and then 2I minus AQ. Before cancellation will be total ionic. Now we got to double check. They all shows up on both sides. Bu2 plus AQ both shows up. 2 minus AQ shows up. 2Cu plus shows up, AQ, and 1SO4, 2 minus shows up. So everything shows on both sides. Make sure you double check. Do you have the coefficient match, the charge match, and the state match? If they are not matching, no cancellation, because actually you did something wrong. So after I cancel everything, actually I have nothing left over. So then my net ionic, you can just write no reaction. So then that's why I write here, I write no reaction. And then the checking why there's no reaction is because you can just write no gas, no PPT, no water is produced. So that's why everything is canceled. Okay.